Describe the transformations. So one transformation, what's happening, Brian? Just one transformation. So which one? Okay. Be careful, because if you have x plus 3, opposite. So it's left 3. Okay? Ethan, what's another transformation? Down 2. Good. Okay. Another transformation. Devin. A reflection because it is negative. Good. Okay, and there's one more transformation. Cooper. Vertical compression. By 1/2. Okay, the vertical compression is the 1/2. The negative means reflection. X plus 3, remember, opposite of what you see. So it's left 3, and then down 2 is the same. Okay, yes.
So the rule for compression is
Stretch.
More than one, it's a stretch.
Mm-hmm.
It's less than one, it's a stretch.
Correct, but with the less than 1,
So it's not negative.
not negative, yes. Yep. Yep. What's the difference? You guys tell me. What's the difference between the two? Cooper. Good. Okay. Vertical stretch is narrower. Okay, getting closer or stretched out, and we're going to see some examples today. Compression is actually getting shorter and wider. Okay. It's vertical. It's vertical. Well, we don't do a horizontal compression. It's vertical stretch and vertical compression. Okay? Okay, so for 2A, we have a quadratic. What is, Lily Wade, what's my vertex? Well, the vertex. So what would be the vertex for a quadratic, the lowest point? Lowest turning point. 0, -3, which remember, your vertex for a quadratic is HK. Okay? So what direction did this graph move in? Lily B. Yep. Okay, this went down 3. So we have 0, -3, and all the points move down as well. And that's our graph. Okay? Yes? Unless it tells you to. Okay. So for B, okay, what is our vertex, Josh?
Our vertex
Okay, our vertex is 1, 4. What transformation happened? Emily? Okay, we originally start with 0, 0. Now we're at 1, 4. Okay. Perfect. Good job. Right 1, up 4. Also, the A value is 1, and that is our slope. Okay, so it's a V shape for absolute value. V shape is absolute value. Okay. Now C, okay, so our vertex is HK for both quadratic and absolute value. For square root, HK is our starting point. Okay, so what is our starting point, Amelia? -4, 0. Good. Square root. Okay. Negative 4, 0 is our starting point. Okay, and that's also our HK. What transformations happened? What is 1, James? Good. Left 4. And Jason, what's another? It's a reflection. So this one I saw a lot of corrections on something similar, okay? If you're not sure what the graph should look like, whatever it is, the starting point is the lowest x value you could have, okay? So we should not input negative 5. We can input negative 3. What that looks like is negative 3 plus 4 is what? Negative 3 plus 4. 1. What's the square root of 1? Times negative 1 because of the reflection. Negative 1. So that's your next point. Now, some of you might say, all right, let's try negative 2. Negative 2 plus 4, what do we get? 2. Square root of 2 is not nice, right? It's a decimal. So, nope. Same with negative 1. We can plug in 0, though. 0 plus 4 is what? 4. Square root of 4 times negative 1. Negative 2. Okay, so your goal for square roots is you want the number inside to be a perfect square once you add x values in. Okay, you want to make it a perfect square. Okay, so this is our square root. It's reflected, and it moves to the left 4. Okay, yes? Reflection of the x, yeah. If it asks, like on that chart, yes, you should. Okay, because there is a reflection over the y, but we're not going through that. All right. Okay, given the vertex form of a quadratic, a, x minus h squared plus k, for what values of a does a reflection across the x-axis take place? Liv. Yep, when a is less than 0. So a is negative. Using the same equation above, using a, h, and k, what are the coordinates of the vertex? Mia. Just leave it. Unless you're graphing it. Okay. HK determines the vertex. Okay. And for this particular problem, the vertex is 3/4 and 7/2. Okay. Any questions on the warm-up? Looking through, some of you did have questions on 2F. Okay, this was 2F on the homework. Okay, what is our starting point? 3, 0. So 1, 2, 3, 3, 0 is our starting point, which is also our HK, which means we move to the right 3. What other transformation is happening? Cooper? Vertical stretch by 2. So, you could do this a number of ways. If I was to plug in an x value right next door, so 4. 4 minus 3 is what? 1. Square root of 1 times 2. Okay. Now, what would be the next x value I can input to make this a perfect square? So I already used 4. What would be? Yeah. 7. So 7 minus 3. Square root of 4 times 2. that's our graph. Okay, so you want to plug in x values, which is going to make this a perfect square. Okay, anytime you are finding x and y intercepts, it might not be on the graph. Okay, might not be on the graph. So we have to find them algebraically. So if we look at 2e, okay, if we look at 2e, to find x-intercepts, and 0 for y, okay, so what that looks like is x minus 3 cubed plus 1 equals 0. Okay. So what we would do here is solve. So we have x minus 3 cubed equals negative 1. Let's fix this. Okay. So we take the cube root. You're able to take a cube root in this answer. I just saw that's wrong. Okay. X minus 3 cubed, okay, plus 1. You could take a cube root of a negative number, which would be what? Yeah. Yep. It would just be negative 1. Then you have x minus 3. You add 3, which would be 2. It should say 2, 0, not 3, 0. 2, 0. Okay. So 2, 0 is your x-intercept. Okay. Now to find the y-intercept, you substitute 0 in for x. Okay. Okay. What is 0 minus 3? Negative 2. Oops, negative 3. Thank you. Negative 3 cubed is what? Yep. Negative 27 plus 1. So that is your y-intercept. So some of you who left it blank or said you couldn't see it, you still could find it algebraically. Yes. Yep. Okay. The other piece of information is, which you guys didn't have to do for this one, but if you had absolute value, okay, absolute value. If we had, for example, this, okay, if we had an absolute value function, okay, and this is important to know because some of you don't remember this, and we need to find the x-intercepts. Okay, you set equal to 0. Okay, you isolate the absolute value. So from this point, you have x plus 3 equals 2, and x plus 3 equals negative 2. Because the definition of absolute value is the distance from 0. So if you don't remember this, I highly suggest you write it down. Okay? Absolute value is the distance from 0, so you have to have 2 equations. Okay? You have to have 2 equations once you isolate the absolute value brackets to find your x-intercepts. So you end up with x equals negative 1 and x equals negative 5. Those are your 2 x-intercepts. Sometimes you might not be able to see them from the graph, okay, but you still have to solve them algebraically. Okay, so with absolute value functions, write this down. Absolute value functions, set equal to 0, isolate the absolute value, And again, you have two equations. Yes? Nope. No. Mm-mm. It's the a value in front determines the slope. Okay? So in cases where you do have a slope of 1, you can use a slope to determine it, but in some cases you might not be able to see them. So you have to solve algebraically. Okay? All right. So any other questions that you guys came across that want to go over? Yep. Huh? Find x-intercepts for absolute value. Yeah. Yep. All right. If you turn to page 9 of your notes, we are continuing today and finishing this lesson. Okay. We are working backwards. Okay. You always have to distinguish what the parent function is. So the parent function could be cubic, it could be square root, it could be absolute value, it could be quadratic, okay? So you first want to determine the parent function, right? Then you want to think about the vertex, starting point, and point of inflection, which is HK, okay? That helps you with this graph a lot. From this point, determine if the graph is reflected, okay? If so, you make that a value negative, okay? From the same point, you determine the slope. Now, the only thing the slope is really going to help is absolute value. Later on, when we get into polynomials, we will determine the a value, specifically, if there's a stretch or compression. In this unit, we'll definitely look at it for absolute value because it's easy to determine, okay? So, for number 1, what is the parent function? Emily. Good. X cubed is our parent function. Now, does this parent function, or cubic graph, use vertex, starting point, or point of inflection? Huh? Not the starting point. Yeah. Point of inflection. However, all of those represent HK, right? So what is the point of inflection here? Jason? Positive 4, 0. Okay. Is this graph reflected? No, it's not decreasing at all. So what would be my equation? Yes, Cooper. Careful. Jason? Good. Anytime the x changes, okay, if you're moving left or right, whatever it is, it's always in parentheses and then cubed, or always in the absolute value brackets, or always underneath the square root, okay? The cube's on the outside. Number 2, what is our parent function? Helena, what's our parent function? Absolute value. So the absolute value uses what? Vertex, starting point, or point of inflection? Jason? Vertex. And what is our vertex? James? Good. Negative 6, 2. This is not reflected at all. The slope is still 1 over 1. Okay. What's my equation? Mia? Awesome. Okay. X plus 6 because we moved to the left, plus 2 because we moved up. Okay. Right. Now number 3. What is our parent function? Good. Y equals x squared. So this is the same thing. Okay. Using the vertex. What is my vertex? 0, 0. But what's happening here? It's reflected. Okay. So what is my equation? Yeah, yeah. Perfect. Negative x squared. Okay, and number 4. What is my parent function? Bill? Good. And this one uses our starting point. So where is our starting point? Cooper? 0, 2. Okay. And how would I write that equation? Go ahead, Jason. Good. Awesome. Okay. Try number 5 on your own. Try number 5. All right. Brian, what's our parent function in number 5? Good. Awesome. Okay. Ethan, what is our vertex? 4, negative 2. Good. Okay. Devin, what's our equation? I'm sorry, you just got back. Our equation for number 5. Are you able to? Okay, you just got back. That's all. Josh, go ahead.
F of x equals 4 x squared minus 2.
What else, Mia? Negative needs to be in because it's reflected. Okay. How many of you did have that for that one? It's opening down. It's upside down. Okay. All right. Yeah. Yep. Okay. So we have done all sorts of parent functions, right? This can also work with your random functions. So turn the page. Okay. This works with your random functions. Okay. Where, if you look at the bottom, these are random functions. Okay, they're not quadratics, they're not square roots, whatever they are, they're just random functions. The transformations have not changed. Okay, A still does the same thing, H still does the same thing, K does. Just the way it's described is different. Okay, so if I have F and then X plus 2, what does that mean in terms of transformations? Yes, Jason. Left 2. It moved left 2. So the notation just looks a little bit different. Move to the left 2. What's happening in B? Yellow. To the right 3. And then C, what is happening? Josh? Good. Left 1 and up 2. So again, what you guys just did is the same exact thing. Transformations AH and K work for all functions, okay? Even if they're random, which we're going to see right now, all right? So these are moving points. So if I have f of x minus 1, what is happening? Mia? Awesome. Because it is on the outside of the parentheses, so it's moving down 1. So all of those 5 points that you see, x values stay the same, y shifts down 1. So -7, -1, -3, 4. I'm going to connect as I go. 2, 4, 6, 7, 9, -6. Okay. In B, what transformations are happening? Yeah. Good. Left 2, down 2. Okay. So focus on the key points that are given to you. So we'll just do the first one and then you guys are doing the rest. -7, 0 will now become what? Careful. Left 2. Left 2. -9. -9. Down 2. -9, -2. Okay. -9, -2. So go ahead and transform all those points if you haven't done so already. Okay. -3, 5 would now become what? What would be my new point? Liv? -5, 3. Good. Okay. 2, 5 will now become what? Alina? 0, 2. Good. And I'm going to connect as I go. 6, 8. 4, 6. Okay. 9, -5. Cooper? Good. Okay. So, the next one. What transformation's happening? Brian? It's a reflection. Awesome. And I'm going to give you guys these points because the graph is kind of hard to see. Okay. This is -5, -1. -2, 2. Okay. So reflection over the x. So if I have -5, -1, what would be my new point? -5, -1. What's the only thing that's going to change? Cooper? Good. -5, +1. Good. -2, 2 will now become what? -2, -2. Good. And again, I'm going to connect as I go so I don't lose track. -1, and then to be -1, will now become what? -1, 1. Good. Okay. And then we know it's going to be 2, 1. How about 4, 3? Good. 4, -3. And then there's one more we could say is 5, 2. 5, -2. Okay. So I want you to keep in mind a few things that happened. Okay, why we did this. Because you're eventually going to be given a point or points to transform them by thinking of what operations, including add, subtract, or multiply, okay, to either x or y. So, for a graph of f of x, the point when negative 7 is given. Okay? I want to determine the new location of this point. If it's transformed by this. Okay? So what transformation is happening? Jason? What transformation, though? You are correct. Right 1 and up 4. And he also gave us exactly what we are doing. Okay? So if we're moving to the right 1, we're actually adding 1 to x. Okay? So my new location for x will be at what value? 2. Okay? Then if I have negative 7, but I'm moving up 4, we are adding 4 to y. So what's my new y value? Negative 3. Okay, so that's your new point. Okay, and that is your new point. So you might be given a ton of different points to determine, okay, what they are. You have to remember, if you're moving to the right, you're adding to x. If you're moving to the left, you're subtracting from x. If you're moving up, you're adding to y. If you're moving down, you're subtracting from y. If it's a reflection, what do you have to do? By doing what? So think of operations. What would you do? Add, subtract, multiply. How did you go from negative 5 to negative 1 to negative 5, 1? What did you have to do here? And this is for anybody. Yeah, Cooper. Multiply the y by negative 1, right? So this is going to be important, especially when you have multiple transformations happening. Which leads us to this. Okay. The last thing where there's multiple things going on. Okay. This is called a dilation. We've done this already where there's stretches and compressions and reflections. Okay. We must multiply the y values of our graph by this a value. Okay. So this is 2 examples. You are going to see actually what a stretch and compress looks like. Okay. So we have same graphs here. Okay. But in A, what types of transformations are happening? I hear some of you like whispering in your mask. Oh, good. Vertical stretch, okay, by 2, which means you are multiplying y's by 2. Okay. So if I had negative 3, 4, what would be my new point? Josh? Negative 3, 8. Here somewhere. Okay. Then if I have 1, negative 1, what would be my new point? Yellow. 1 what? Careful.
Oh, sorry.
Negative 2. Good. 1, negative 2. Okay. Then if I have 2, 3, what would be my new point? Cooper? 2, 6. And we already know the last one. 4, 3 would be, 4, 6. Okay. So that's where the stretches occur. It gets longer. Okay, it stretches out. Now if you look at B, what's happening? There's 2 things. What's happening? Yeah. Okay. reflection, and compressed. Okay? Both vertically. So, since these are both happening to y at the same time, you can multiply your y values by just -1/2. You don't have to do it separate. You can multiply by -1/2. So if I have -3, 4, I'm just writing these down again. Okay. So -3, 4, what would be my new point? Yellow. -3, 2. Good. So -3, 2 is here. Okay. How about +1, but -1/2? I mean -1. Yeah. 1/2. Awesome. Okay. And then 2, 3 would be what? Yeah. Good. 2 and -1.5. Okay. And then what else would we have? Oops. I graphed this one wrong. -3. This should be a -2, guys. Did you guys catch that? That's why it looks different. Okay, because 4 times -1/2 was -2. Okay, -3, -2. I was wondering why it looked so weird. 2, -1. And then we have 4, -1.5. Okay, so just be careful of your signs there. So if you notice, it is compressed. It got very tiny, actually. Okay, as opposed to the purple in the other graph where it's stretched out. Okay. So what do you do if you have multiple things happening? Okay, these are the last two things today. Okay, what do you do when you have multiple things happening to our y values? Okay, you have to remember PEMDAS. Okay, where if you have an A and a K, the A has to happen first. Okay, so that's important. If you have a stretch or a shrink or a reflection, that has to happen first before you move up or down. Okay, so reflection, stretch, or compression has to happen first before you move up or down. Okay, all right, so looking at this first graph here, okay, and we're going to go in order and transformation, so as you read it left to right. What's the first one? Vertical stretch. And this is the first thing you have to do. Vertical stretch by 2. Okay? Then what happens? Yes, Josh. Good. Right 4. Okay? Then what? Yeah. Then down 1. So we know right 4 affects the x, so that could be done at any time. However, vertical stretch and down 1 affect the y. So this has to happen first. You have to multiply first. I'm going to give you points to work with, which we're going to do too. We have -5, 1. We have -3, -1, 3, -1, and then 5, 1. These are the points we're going to transform. Okay? Okay. So, we could do the stretch and write 4 first, okay? So if it's a vertical stretch by 2, what's happening? Yeah. God bless you. Multiply each of the y's by 2, okay? So if that's the case, I go from 1 times 2 is 2. Then I have negative 2. Okay. So right now, what we just did is took care of the vertical stretch. Okay. Now, if I'm moving to the right 4, what am I doing to x? Right 4, Liv. Adding 4. Okay. So negative 5 plus 4 is what? Negative 1. Negative 3 plus 4? 3 plus 4? 7. 5 plus 4? 9. So what we did right now is just take care of right 4 and vertical stretch. But what's left? Yeah. Subtract y's by 1. So my x is going to stay the same. I'm just subtracting my y's. So 2 minus 1, 1. Negative 2 minus 1, negative 3. Then we also have negative 3, 9, 1. Okay, so in the blue, those are our final points. Negative 1, 1, negative 3, 7, negative 3, and the other one's off the chart. But okay. This is an arrow. Okay. So, by taking you step by step, you know that, hopefully, stretch, shrink, or stretch, compression, sorry, or reflection have to happen first. Okay. Then moving up or down. All right. Okay. Now, for the last one, we're just going to distinguish. I'll give you guys the points so it's easier to see. Let's see my cards. Lily Wade, what's one transformation? The first one. I'm going to put that as number 2, but you are right. Left 2. Okay. Let's see. Emily, what's another one? Reflection over X. Good job. Okay. And the last one, Amelia. Up 3. Good. Okay. So you guys could do the points. Jot the points down if you want to. I will give you these so you could see them. Didn't matter what I did. Couldn't get this graph clear. Okay, so go ahead and transform those. Okay, transform that graph. We'll check the points in a few minutes. So, for negative 5, negative 1, what would be your new point? Josh? Negative 7, 4 is correct. How many of you did have that? Good, okay. Negative 2, 2. Jason? Negative 4, 1. Good. Then we have negative 1, negative 1. Josh? Careful. Careful. You have to reflect it first. Okay. So you have -1, 1, but I move to the left, so -3, 1. Then I have to add 3. So -3, and then 1 plus 3 is 4. Okay?
So I wrote the 4 with the positive order. That's why I wrote
Yeah, that's why. Yep. Okay, 2, -1. Jason? 0, 4. Okay, and then 4, 3. Yep. 2, 0. Yep. Yep. Yeah.
I want the X values correct, but not the Y values.
Okay. Okay. So for -5, -1, right? And I'll move it to the left too, or just keep it. So for the y's, -5, -1 becomes -5, 1 because of the reflection. Then I'm moving up 3. 1, 2, 3. Okay. So remember the reflection has to happen first. Okay. Any questions? Yep. Yep, you should. Yeah.
I grabbed it and I was kind of confused, but I touched it how it's reflected in also.
Yeah. And plus, we don't see the whole graph. So -7, 4 somewhere up here, somewhere. -4, 1. -3, 4. 0, 4. 2, 0. Oops. 2, 0. And then this one, if it was 5, 2, it would be, yeah, 3, 1. Is here. Okay, so that's what the graph would look like when you graph it. Shows the reflection, and up 3, left 2. Okay, so we just completed our transformations. Okay, I know it seems like a lot, but weren't they the same? Doesn't matter what graph was thrown at you, all the transformations were the same. Meant the same thing. It just got a little difficult at times remembering the operations if you're given points, which you will see. Okay, so your practice, you have about 25 minutes to even start and complete it. And one thing I will say on your practice, some of them will be left blank intentionally. That still means to complete them. Okay, some of them will be left blank intentionally. That still means to complete them. All right, so on page 13, which is the 1.5 practice, okay, page 13 is 2D, all of 3, okay, page 14, all of number 4, okay, hold on 1 second, hold on, I'm going to get to that in 1 second, I just want to finish my thought. 1.5 practice 2 on page 16. 1 to 3, and then number 5, and page 17, 7A, and 7B. Okay, so if you guys go to number 3, 3E, change to cubic, not cube root. Okay, change to cubic, not cube root for number 3. Okay, it says cube root reflected over the x, 10 up. Okay, cubic function. All right,